Okay, so let's talk about sinusoids. Sinusoids are sine or cosine waveforms that can describe many engineering phenomena, such as the heart measuring per second or even the swinging of an object. As we can see on the right is the pendulum. Basically, it describes oscillatory motion and exists at all times. So we can say that it never turns off or on in reality. It just goes on for infinity. Sinusoids can be modeled in different shapes such as square, modular, or triangular waves. Sinusoids are composed of very important things, which are the amplitude, frequency, and phase. The amplitude is the height of the wave from peak to the center line. Frequency is how often something happens per unit of time. For example, in the diagram below is a cosine function that repeats 4 times between 0 and 1. Therefore, the frequency is 4 and the period is 1/4. The unit usually used for frequency is hertz or radians per second. Phase offset is a shift in peak rotation. As you can see in the diagram, one full cycle of the circle is equal to the wave depending on how it's set below. Following up is a code used in MATLAB to create a sinusoid. If you're interested in seeing how this was created, there will be an explanation in my next video. Two types of signals are continuous signals and discrete signals. A continuous signal has a number that is measured at any instant. A discrete signal, however, is composed of numbers taken at any time but are not precise or not measurable. For discrete time, signals can also be expressed as radians per sample, which is a dimensionless quantity. The next slide portrays the similarity of a complex number and sinusoid, which are the magnitude and phase. Then, we need to know the sinusoid equation formulas and the meaning of each variable. Also, be familiar with the unit circle in trigonometry, as when solving problems, it is very important to understand how it works, especially when talking about sinusoids. Finally, always use radians when calculating at all times instead of degrees. For example, finding the sum of two sinusoids. In this question, we add the common factors from each equation, but before we do that, convert it to Cartesian notation. For x2, I looked at the unit circle and went back pi, which is 180 degrees, and back an amplitude of 5. I did the same for x1 and then finally added both equations together to get x3. Ultimately, when we look at two sinusoids in one graph, they are in phase if they have the same peak and frequency. If they're out of phase, the peak is not aligned in the graph. Therefore, the phase difference can be predicted based on 1 cycle per second. There are different ways of showing the phase difference. For example, through analyzing the graph and finding the percentage phase difference by dividing 3 to 100%, which equals to 33.3% in one cycle. Also, we can be given a mathematical equation, like in this case, and the main idea to take out of this is to have cos in both equations and have the same sign. To do so, we look at the unit circle, which is drawn on the screen, and go back 90 degrees from minus sin to cos. We also add 90 degrees to the angles, and therefore combining the angles to get the final answer of 115 degrees.